Done and dusted. So hi once again. Hello, hi, and this is. So we were doing dynamics of circular motion. We did something. We got to know how to consider centripetal frame and centrifugal frame. Then I told you have to do most of the question in which frame? Cheetah frame, isn't it? Yeah. And then we did two questions. We'll continue with some basic kind of question and then I'll make a turnover of this. Today will be almost around the last class of circular motion. Then we can jump on to work energy and power. Okay. So not last or I think second last. One more class I might require to cover up some of the basic more facts and then we can move ahead. Okay. Okay, so whatever we did, 1 minute, let me adjust perfectly. Yeah, so whatever we did, we started with something, and then we got to know for the pendulum case, isn't it? Again, I'm going to pick up my pendulum case only, but this time this is little bit arbitrary. Okay, so is little bit different. So previous case, I took out means the full vertical position, isn't it? Now I'm considering. Yeah, so this time this mass is present over here and it's making some, let's suppose some angle theta with the horizontal axis, sorry, vertical axis. Okay. And at this instant of time, I'm perfectly aware of my velocity of the particle and it is given as v. And the question arises, what value, if the mass of this particular bob is m, then what value of tension must be present to balance the bob. ठीक है? And if the length of this particular thread is L. ठीक है? Yes. Tell me. Think. Yeah, what? MV square by R plus? Okay, yeah, it's perfectly correct. But acha, you tell me there is a little bit of slight thing. So this is my tension, isn't it? This in this direction, the tension will be always present. Tension has a direction always towards the direction of the wall if I'm considering this particular kind of motions, isn't it? Now, the mg will be perfectly vertically downwards. While yeah, but if I see this particular motion, the circle inscribed over here will be something like this way or not? Yes. So basically, can I visualize that this L is working like a radius? Yes, because pendulum is always a yeah. So basically, the m for cheetah frame, if a cheetah sits on this particular mass, then mv square by r will be present outside, which will be mv square by l, isn't it? That's what is correct. Now the question arises that, sir, why we didn't did one thing? Why we can't do two things? Like I can even resolve like this way now that this is my t cos theta and this is my t sine theta. And then I'll resolve all these components and then I'll write t cos theta is equal to mg and t sine theta is equal to mv square by l sine theta. Can I write like that way or not? But then why this is incorrect while this is only correct, that you have to only consider, basically the rule is that you have to take this theta over here, and then once again I'll have one more component of mg, which is mg cos theta, and then I'll write tangent t as mv square by l plus mg cos theta, isn't it? This is my value of tension. But why didn't we went through this particular method of resolving into t cos theta and t sin theta? Why this method is incorrect, isn't it? So see this. Yeah, that's what I will say you. When I am considering t cos theta and t sin theta now, what is happening is that okay, t cos theta is balancing my mg, t sin theta is balancing at that instant of time only one component of mv square by l. Another component is still left out or not. So that is why it is not getting considered. Next thing is when you consider this mg, when I have this t cos theta and I have this as t sin theta, this is my mg. So this is mv square by r. Okay. So when I am considering this particular kind of formation, and in this direction there is velocity present over here. So what is happening basically, if you see over here, this velocity goes on decreasing or not? Yes, the velocity will in pendulum. If it is a pendulum, yes. If it is a pendulum motion, the velocity will goes on decreasing. That means in this particular direction there is a presence of and some kind of another acceleration or not in the opposite direction, which is reducing that velocity. So basically, when you are applying this t cos theta and t sin theta, you have to also include that acceleration case also. Are you able to get me or not? So that is why it becomes complicated, and that the things become hard and we can't do it. Are you able to get me or not? So the better idea, yeah, that's what is. That's what is. It's not incorrect. It's just complicated. Okay. Yeah, that they can do it, but ultimately they will have to consider this acceleration component also and all those kind of things. Okay. Is this clear or not? So that's why the most common approach is just to follow, just to resolve the components along the direction of tension. What is the condition? Resolve along the direction of tension, and then you will get the answer. Are you able to get me or not? Understood? Okay, so I'll move ahead. So basically, this is what we did. What we did is we just considered the normal case. Then I went to the vertical case. Now I can have one more kind of pendulum motion. I can have still one more prototype. And what I will do is, let's suppose if this is my vertical, okay, I can have the pendulum, okay, I can have the pendulum with this particular bob and I can rotate it in the horizontal circle kind of motion or not? Yes. So then, if it is rotating in this particular kind of horizontal circular motion with some kind of angular velocity omega, right or not? So look over there. It's completing a full circular motion or not? So basically, I'll have to take omega or v. I'll have to take omega. I have told you for a smaller reason, you have to take v for if this is kind of if our body is doing this kind of circular path. Okay, means a very small path. Then you have to consider velocity, and if it is a full circular motion, then you have to consider omega. Are you able to get me or not? You didn't got that point. Okay, I'll come on that. Okay, just right now, next part I'll discuss that only. So let's suppose if it is rotating with angular velocity, how much? Omega over here. Are you able to get me or not? Let me write perfectly. Yeah, so this has angular velocity omega, and the length of the thread is L. And at that instant of time, if it is making angle theta, and if it is M, then the question is find angle theta for which body does horizontal circular motion. Do it. बताओ क्या हो, टोटल विद द कंडीशन। अच्छा, एक एक बात ध्यान से देखो, इफ आई कंसिडर दिस पर्टिकुलर काइंड ऑफ हॉरिजॉन्टल सर्कुलर मोशन, its radius is length L, or its radius is this particular length which I have drawn right now. It will not be length L, no? The radius will be this particular length, no? Which is over here. So this is L, this is theta. So radius can be considered as L sine theta or not? Yes. So length. This is my radius only, no? Look over there. You got it. So now, if I just take, see this in this direction, there will be my tension T. mg will be vertically, यहाँ पे T को ही रिजॉल्व करेंगे. So mg will be vertically downwards, isn't it? And now look over it. If I This is my circle right now. So for this mass, the centrifugal force means the particular centrifugal force will be always radially outside or not. So this time it will be not in this direction. It will be in this particular direction. Are you able to get me? And yeah, so this will be how much? M omega square L sine theta. Are you able to get me or not? So this m omega square L sine theta with respect to which frame? Non-inertial frame. Remember that this is with respect to which frame? Theta frame. Means an observer sitting on the particle itself. And if the observer sits on the center, then the particular direction of this particular thing will be inside. Are you able to get me or not? Okay, so now then if I consider tension T, now once again what we observe that now it has appeared that this tension can have two components right now. One will be, yeah, and this will be T sine theta. So basically I can write T cos theta is equal to mg, and T sine theta is equal to, yes, m omega square L sine theta, and then we can take the particular tan theta ratio, which is m omega square L sine theta divided by mg. So cancel, and we got tan theta is equal to what? It is coming in terms of sine theta. Okay, so it's appearing, 1 minute, it will appear in cos theta, I think so, isn't it? Because there is one more sine theta. This sine theta will get cancelled. Okay. So basically, tan theta is nothing but sine theta by cos theta. So 1 by cos theta is going to be equal to omega square L by how much? G. Are you able to get me or not? So then cos theta can be written as G by omega square L, and theta is equal to tan inverse. What I got it? Tan in, sorry, cos inverse G by omega square L. Are you able to get me or not? सही है, फील हो रहा है अभी कि सर अच्छे से सर्कुलर हो रहा है? हो रहा है ना? बस. So basically this is what you have to understand. Every time you have to think like in this particular sense only that what is happening. अच्छा, तो देखो, ये जो सारे केसेस थे ये वर्टिकल वाले केस हो गए है ना. अब मैं एक काम करता हूँ, अपन अब इसके ऊपर एक अच्छा ये क्वेश्चन है, इसको बाद में करते हैं ना, इसको थोड़ा देर बाद लाते हैं ना, ठीक है, लास्ट में इसको करेंगे। अच्छा इसके इसको जो है हम एक पर्टिकुलर वे में और भी ट्रीट कर सकते हैं। हाउ आई विल ट्रीट इट नाउ, basically I can even attach this circular motion with the surface. Till now you considered all the circular motion which were not attached with the surface. Now circular motion with the surface I can even consider or not. Like I'll tell you right now, consider, let's suppose if I have any kind of disk, okay, this is my disk, okay, now this, 1 minute, okay, it's always same, perfect or not perfect, yeah, this is my disk, yeah, so consider this as your disk, okay, and this is present in horizontal direction, okay. Now I attached one particular rod with it, and then I started rotating this rod with angular velocity how much, omega. So this disk will also start rotating with angular velocity omega or not? Yes. So now let's suppose if the radius of this disk was r, if the radius of this disk was r, and on this disk what I did, I placed one particular block of mass m exactly at the corner. I placed a block of mass m exactly at the corner. Question is that what, अब तुम एक बात बताओ, तुम खुद सोचो जरा, अगर ये डिस्क रोटेट करेगा तो ये जो मास m का जो ब्लॉक है वो नीचे गिरेगा या नहीं गिरेगा? It will fall definitely. So then there should be something which will not make this mass m to fall or not. Yes. तो क्वेश्चन पूछता है, फर्स्ट क्वेश्चन पूछता है कि value find value of coefficient of friction required required so that, अच्छा इसमें एक एक काम करते हैं, इसमें तो कोफिशिएंट ऑफ फ्रिक्शन से कोई मतलब नहीं, अगर ओमेगा बढ़ाते गया तो वो तो गिर ही जाएगा अल्टीमेटली। बेसिकली एक काम करते हैं, बोल रहा है, क्वेश्चन थोड़ा सा चेंज करता हूँ, ठीक है, क्वेश्चन इसलिए चेंज करता हूँ क्योंकि आई टेल यू व्हाई आई चेंज द क्वेश्चन। क्वेश्चन पूछ रहा है कि फाइंड द वैल्यू ऑफ मैक्स ओमेगा, बोल रहा है कि अगर ये ब्लॉक मास m के ऊपर एक फ्रिक्शनल फोर्स फील हो रहा है म्यू का, अगर कोफिशिएंट ऑफ फ्रिक्शन बिटवीन द डिस्क एंड द ब्लॉक इज हाउ मच, म्यू, देन फाइंड ओमेगा मैक्स फॉर व्हिच द ब्लॉक विल नॉट फॉल। हाँ देखो फ्रिक्शन ऐसे, देखो फ्रिक्शन तो हरदम रहेगा, म्यू की वैल्यू तो वैरी नहीं कर सकती है ना, नहीं कर सकती। तो इसका मतलब क्या हुआ कि अपने पास, अपन को ओमेगा को ऑप्टिमाइज करना होगा, ओमेगा की एक पर्टिकुलर मैक्सिमम वैल्यू ही हो सकती है, अगर अदरवाइज क्या हो जाएगा, अगर ओमेगा उससे बड़ा हो गया तो ब्लॉक क्या कर जाएगा, गिर जाएगा, है ना? तो यू हैव टू थिंक इन दैट सेंस पर्टिकुलरली। या थिंक वाइजली। फाइंड द ओमेगा मैक्स फॉर व्हिच द ब्लॉक विल नॉट फॉल, मतलब देखो खुद सोचो, अगर एक डिस्क, ऐसा होना चाहिए, बताओ, तुम खुद बताओ। अच्छा एक बात बताओ, अगर 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 कोई चीज रोटेट कर रहा है, ठीक है, अगर मान लो अगर किसी चीज को रोटेट कर रहा हूँ और किसी ब्लॉक को यहाँ पे ऐसे पार्टिकल रख दिया बीच में, तो देखते हो ना कि वो पार्टिकल बाहर की ओर जाने लगता है कि नहीं? अगर मान लो किसी डिस्क रोटेट कर रहा है, जैसे वो तुमने वो देखा है क्या, वो डांसिंग वाला वो जो मेला होता है, जो अपन का मेरी गो राउंड होता है, मेरी गो राउंड में देखे हो ना कि जैसे ही मेरी गो राउंड में बैठते हो, तो वो जो घोड़ा वगैरह होते हैं वो कहाँ जाते हैं, बाहर की ओर जाते हैं ना, कि अंदर की ओर रहते हैं? देखो, बाहर जाते हैं। So that means that there is some force which is pulling the mass outside or not. And then, so so basically, if I told you that day that if any body is attached, if this is rotating with omega, so this mass m is also going to feel a particular angular velocity of omega or not. And this is my radius r, so this mass m will feel an centrifugal force outside, which is going to be how much, m omega square r. So see this. So this is my mass m. This is my mass m. Basically, this is my mass m. This is filling and centrifugal force outside, which is m omega square r. So there must be some frictional force which will be present. Means there will be some frictional force. Yes. So basically, this frictional force must be always greater than or equal to m omega square r. Then only the particular thing will never ever fall. Now, isn't it? If m omega square is more than frictional force, then definitely it will fall. Now, the particular value of friction can take up to maximum frictional force, isn't it? So m omega square r must be greater than f, m omega square must be less than or equal to f max. Then only the block will stop, isn't it? So what is the value of f max? Mu into normal. So that must be greater than m omega square. और ये मेरी बात समझ में आ रही है ना, कैसे लिखा मैंने f max? क्योंकि हाँ, क्योंकि जो फ्रिक्शन होनी चाहिए, फ्रिक्शन की मैक्सिमम वैल्यू एफ मैक्स होती है, ठीक है, और एम ओमेगा स्क्वायर को उस एफ मैक्स से भी कम रहना है। आर एबल टू गेट मी और नॉट? ठीक, तो म्यू इनटू नॉर्मल, अब ध्यान से देखो तो weight of the block mg is downwards and the normal will be upwards or not? Are you able to get me or not? तो नॉर्मल की वैल्यू क्या होगी, mg, सो म्यू इनटू mg मस्ट बी ग्रेटर देन m ओमेगा स्क्वायर r, mm कैंसिल, और म्यू, sorry, omega must be less than root under mu z by r, then only the block will not fall. Are you able to get me or not? Mm-hmm. Is this clear? समझ में आ रही है चीजें? ध्यान से देखो, तो बेसिकली व्हाट वी आर डूइंग नथिंग, वी आर जस्ट ब्रिंगिंग टू और थ्री केसेस. सी वी डिड मेनी थिंग्स बिटवीन दीज डेज. We did each and every kind of formations, each and every kind of understanding what is the meaning of inertial frame, what is the meaning of non-inertial frame, what is the meaning of this relative angular velocity. All these everything we completed. Basically these are all the parts of circular motion only. They actually creates an understanding that what can happen for the circular motion and what can basically be understood out of circular motion. Is this clear or not? So these all are basic meanings of the circular motions. How we are doing the dynamics depends upon all those things which we learned previously. ठीक है, थोड़ा सा इसको टफ करूं मैं, इस डिस्क के प्रॉब्लम को टफ करूं? शुड आई मेक इट लिटिल बिट टफ? ओके, कंफर्म? ओके, तो लॉक करते हैं. यू ओनली टोल्ड मी सर प्लीज लॉक इट, एंड आई एम गोइंग टू लॉक इट. ओके, सो नाउ सी what it is saying that there is a table. ठीक है, एक टेबल है, ठीक, एक टेबल है अपन के पास, और उस टेबल के अंदर एक पर्टिकुलर ऑब्जेक्ट को मैं क्या कर रहा हूँ, एक सर्कुलर पाथ में दौड़ा रहा हूँ, ठीक है, मतलब एक सर्कुलर पाथ में दौड़ाने की टेंडेंसी रखता हूँ, है ना? Basically there is a table, and on that table what I did कि I just took one nail एंड देन आई मैंने इस नेल को ऐसे ठोक दिया इसके अंदर, है ना, और उससे एक मैंने एक धागा बांधा, उस धागे के साथ एक मास एम के ऑब्जेक्ट को अटैच कर दिया, ठीक है, उस टेबल के ऊपर। आर यू एबल टू गेट मी और नॉट? एंड द लेंथ ऑफ दिस थ्रेड वाज एल, ओके। So basically this mass aim, first you have to tell me this mass aim is doing horizontal motion or vertical motion? इसमें क्या सोच रहे हैं बताओ जल्दी से, हॉरिजॉन्टल या वर्टिकल? Yes, so this mass aim is perfectly doing which kind of motion? Horizontal. We can, हाँ. So basically this is a kind of horizontal motion, means we have a table, means ऐसे मैं टेबल सामने तुम रखी हो, टेबल के ऊपर एक तुमने नेल लगा दिया, नेल के आगे एक धागा बांध दिया, धागा के साथ मास एम को अटैच कर दिया, और इस मास एम को गोल 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 सर्कुलर मोशन में घुमा रहे हो, है ना? तो घुमाने के लिए I'll provide some initial velocity or not? I'll definitely provide some initial, oh, 1 minute, I'll definitely provide some initial velocity, ठीक है। बोल रहा है कि if the coefficient of friction between table and mass m is mu, क्या बोला कि the coefficient of friction between the table and mass m is how much? Mu. Then find the tension T with respect to or after time t. बहुत अच्छा क्वेश्चन है, यू हैव टू थिंक इट इंट्यूटिवली। इट्स एन ऑसम क्वेश्चन, टू मच ऑसम क्वेश्चन। ऐसे क्वेश्चन मिले हैं कभी तुम्हें? हम्म। देखो, क्वेश्चन गिव्स यू द हिंट ऑफ सॉल्यूशन, रिमेंबर दैट एवरी टाइम, रिमेंबर माय वर्ड्स, a question provides you the hint to solve a question, okay? Means basically a question itself is a solution, remember that. This statement is very precise statement, every question is always a solution, remember, if you can read it properly। अच्छा देखो, चलो मैं तुम्हें आज सिखाता हूँ, एक चीज सिखाता हूँ कैसे बनते हैं प्रो इन फिजिक्स, हाउ टू बिकम प्रो। So I do not give these ideas to anybody because this is how I have done. So basically इसमें लिखा है ना coefficient of friction is given as mu, isn't it? Then identify what mu can do. Mu will always reduce the velocity or not? So if I reduce the velocity, then if my velocity gets reduced, of course the particular velocity, if this mass m, think of this particular case, if this mass m appears over here, okay, this mass m came over here right now. So at this instant of time, when the mass m is present over here, at this instant of time, this will have a different velocity or not? Why? Because mu would have decreased it. So does my velocity is changing with respect to time t or not? So if your velocity is varying with respect to time t, definitely the tension will vary with respect to time t or not, because tension t, if you see this circular motion, this is my circle, this is my mass m on the circular path, which has velocity v at any instant. So basically this time the tension is nothing, tension is present over here, and the centrifugal force will be mv square by r outside or not. There will be no component of mg cos theta, mg sin theta. Why? Because the motion is not happening in vertical but direction. Are you able to get me or not? मेरी बात समझ में आ रही है? Yeah, means vertical में ही कर पाएंगे ना. Basically this motion is happening in what sense? Basically if you will be in class, I can understand you in much more perfect way because these things requires visualization. Okay, no problem. I'll show you. Okay, so this is my kind of circular motion which is happening in horizontal, isn't it? And this is my thread with which I have attached my mass m. Okay, so basically you can visualize like, okay, can I just change it into 3D diagram? I do not know. A minute, let me check. Is it possible? We had that something called as 3D steps and all. Don't know. There used to be some 3D diagrams. I'll show you later. Okay. So basically, if I just uh, I can rotate it, but it will not give me anything. So leave it. This is my mass M, which is attached over here. This is doing the circular motion like this way. Now this is basically horizontal, isn't it? Perfectly horizontal. So if it is perfectly horizontal, then what will happen? There is no such component of mg or something like that, isn't it? कुछ नहीं होगा ना. I'll show you 1 minute. Let me just check on Google if there is an image or something like that. 1 minute. I'll circular motion on table. Basically, I'll utilize that table case for many cases. That's why I need that image. Yeah, now I got it. Wow, awesome thing. ठीक है. Copy image. That's all. बस हो गया अपना काम. अपन गूगल पे यूज अच्छे से करते हैं ना. 1 minute. Just delete this thing. I'll show you perfectly. Control B. Yes. Now it has appeared. Now can you see this? So see this. This is what is basically happening over here. This is my mass M, which we are talking about from such a long time, isn't it? Now see, the mg is this vertically downwards, isn't it? Mg is in this particular direction or not? So the tension T, basically this is my tension T. And at that instant of time, it has some, in this particular direction, it will have some velocity V. Are you able to get me or not? So basically the centrifugal force will be horizontally outside, which will be how much? mv square by r. Are you able to get me or not? So there will be yeah, there will be no component of tension which will be required to balance this mg. Just the normal is balancing my mg. Are you able to get me or not? So when you have horizontal circular motion on the surfaces, the normal basically balances mg. That you have to always remember. Is this clear or not? Understood? So basically this is an awesome picture. Okay, I'll keep it over here. So now, basically, I know that at any instant of time, my tension is nothing but T is equal to mv square by r, where this radius is nothing but the length of the string. Are you able to get me or not? Now, this velocity is changing. See, this tension will remain constant. I'll write all the cases. This tension is going to be constant if the table is frictionless. है ना. फ्रिक्शनलेस रहेगा तो वेलोसिटी कैसी रहेगी? फ्रिक्शनलेस है तो बेसिकली हो क्या जा रहा है कि अपन की वेलोसिटी जो है वही, basically velocity is constant, and that is why my tension remains constant. Are you able to get me on? So if I have now, what is happening? Basically, I have something different kind of means I have friction present over here. So the velocity with which it is going right now, this velocity will change when the body will move forward, isn't it? Are you able to get me or not? So when this body has appeared over here, let's suppose when this mass M has came over here, at this instant of time, over here it has a totally different velocity. Are you able to get me or not? It's decreasing. So this is my different velocity. This is different velocity. I call this as Vt. So initial velocity will be V, and this final velocity will be V final T or not. So then the tension will be equal to what? M V final T whole square divided by length L. Are you able to get me or not? Understood or not? Is this clear? Divided by length L. So the task is to find this V final T. Understood? You have to find the V final T or not? Yes. So basically, if I just see this, if I visualize this, can we say directly, sir, basically there is a ghost which is present, there is a ghost which is appearing over here in the backward direction, of velocity. And why pseudo force? I'll call that as an acceleration, and this acceleration is retarding acceleration, isn't it? Basically the friction, this velocity will goes on decreasing. Why? Because there is an पीछे से पीछे से आ क्या रहा है, सिंपल सी बात है, फ्रिक्शन तो इसको रिड्यूस करेगा ना, तो एक्सेलरेशन कहाँ प्रेजेंट है? पीछे की डायरेक्शन में। आर यू एबल टू गेट मी और नॉट? तो बट द क्वेश्चन अराइजेस, व्हाट इज दिस रिटार्डिंग एक्सेलरेशन? निकालेंगे ना अपन। तो ध्यान से देखो, अगर मान लो इस मास एम को कंसिडर किया, तो जो पीछे की डायरेक्शन में फ्रिक्शनल फोर्स होगी वो हरदम देखो, फ्रिक्शन का काम क्या कर रहता है? वेयर इज द डायरेक्शन ऑफ फ्रिक्शन? सी, दिस क्वेश्चन इज टू मच conceptual based. First you have to see that which thing is reducing velocity. Simple, friction is reducing velocity. Next, I got that friction is reducing velocity, but then the question is, which is the direction of friction? So friction direction is always opposite of the velocity. Remember that. Not opposite of acceleration, opposite of velocity. Okay. So friction will be always present opposite of velocity. Then the question arises that due to this friction, if the particular force is present in opposite direction, that means there is a acceleration present in opposite direction. And then how to find that acceleration? So I can write that this mass m into its acceleration must be exactly equal to frictional force, and that will give me the acceleration in backward direction or not. And what is my frictional force? Mu into normal, mu mg, because body is in motion. So tangential acceleration in opposite direction is how much? Mu into g. You got your tangential acceleration, you have the velocity. Then v final after time t is nothing but v initial minus acceleration, sorry, v initial plus acceleration into time t or not. So v initial is v, acceleration is in opposite, so minus, and that is mu g into time t. This is my final velocity. So tension becomes m into v minus mu g t whole square divided by length L. Are you able to get me? Is this clear? Yeah, I'll definitely एक बार पहले देख लो, फिर मैं एक्सप्लेन करता हूँ. My goodness, light has went. Is this screen is visible now? Okay, means everything is fine now. That's all. Let it be. Yeah, it came. देखो, once again, I'll tell you. I'll tell you now. Now I'll tell you. See what is happening. This is my circular motion. ठीक है? ध्यान से देखना. हुआ क्या? तुमने एक थ्रेड लिया. थ्रेड को मैं ऐसे बता रहा हूँ. मास एम के साथ अटैच कर दिया. ठीक है? इसके पास अभी एक वेलोसिटी v थी, ठीक। मैंने पूछा इस टाइम पे जो टेंशन था वो एग्जैक्टली एम वी स्क्वायर बाई आर के बराबर था, है ना? अरे गेट मी। अब ध्यान से देखो, तो बेसिकली दिस टेंशन T is exactly equal to mv square by r at this instant of time. Now, what is happening? I told you that there is a friction present over here. So that friction, what is the work of friction? This will decrease the particular velocity of the body. That means due to the friction, basically the frictional force will be present in opposite direction of velocity or not. And if it is a horizontal circular motion, you right now you got it that this body is like this. This is my mass m having velocity like this, and this is my normal. This is my mg. So frictional force will be in opposite direction, which will be how much? Mu mg or not? It will be mu mg. So look over it. This frictional force will be how much? Mu into m into g. Are you able to get me on that? Is this clear? So basically, this frictional force is generating an retarding acceleration in this direction or not? Yes. So what is the formula? Frictional force is equal to mu mg, but force is mass into acceleration. So you got the acceleration in the backward direction, which is nothing but mu into g. Understood? Centrifugal force. हम देखो, सी, देखो मैं कुछ देखो उसके ऊपर अभी मत जाओ। जिस डायरेक्शन में ये फोर्स है, देखो इसमें देखो ये जो सेंट्रीपिटल फोर्स है, वो भी तो एक तरह का एक्सेलरेशन क्रिएट कर रहा है या नहीं कर रहा, जिसको हम सेंट्रीफ्यूगल एक्सेलरेशन बोलते हैं। तो how do we write it? This force is exactly equal to mass into acceleration, and you'll get the acceleration in that particular direction or not? ठीक है, कंफ्यूज नहीं होना है। देखो सिंपल सी बात है, हमें चाहिए टेंशन की वैल्यू, ठीक है। टेंशन की वैल्यू होगी एम वी स्क्वायर बाई आर, इतना हमें पता है। लेकिन ये जो वेलोसिटी है वो कॉन्स्टेंटली क्या हो रहा है? चेंज हो रहा है। क्या हो रहा है? चेंज। दिख रहा है ना क्यों चेंज हो रहा है? क्योंकि पीछे की डायरेक्शन में क्या लगा हुआ है? फ्रिक्शन, जो इस वेलोसिटी को हरदम डिक्रीज कर रहा है। आर एबल टू गेट मी और नॉट? सो इफ देयर इज एन फोर्स इज इन दिस डायरेक्शन, दैट मींस देयर इज एन एक्सेलरेशन इन अपोज दिस डायरेक्शन और नॉट? So how to find that acceleration? Simple. Force is equal to mass into acceleration. So you'll get the acceleration in opposite direction, which we call it as tangential acceleration. Simple. Are you able to get me or not? See, in a circular motion, there are two kinds of acceleration. One, see, I told you that day that in the direction of velocity, there is a presence of tangential acceleration also or not. So this tangential, if it is present in the same direction of velocity, and after some time, this velocity will increase. This v final after time t due to this tangential acceleration will increase. But if it is present in opposite direction, it will goes on decreasing the velocity. So then the relation of this v final with respect to tangential acceleration will be what? V final is equal to v initial plus acceleration into time t. Why? Because tangential acceleration is in the same direction of velocity. Are you able to get me? So this equation, that's why I told you to reduce the whole circular motion in terms of tangential and radial component, because you can write the equation of motion in a easy form. So देखो, तो इसलिए मेरे को जैसे ही टेंजेंशियल एक्सेलरेशन मालूम चला, मैंने v फाइनल का इक्वेशन लगा दिया, मेरे को v फाइनल आफ्टर टाइम t मिल गया, which is v minus mu gt, and that is my tension. Are you able to get me or not? Got it? बोला था ना अच्छा क्वेश्चन रहेगा। हाँ, you have to think a lot. Yes, there are some questions which I will make you to think a lot. ऐसा नहीं खत्म हो जाएगा, है ना? Is this clear? One more table thing should we do? One more question of table. Means that's why to cry. It's an awesome thing you are getting all these kind of questions, isn't it? Think like that way. Many, yeah, many people. Or actually, if you look at the NEET and J things, they ask NEET in this NEET kind of exam, they ask the same kind of questions, isn't it? Right? It decrease नहीं हो रहा। हाँ। हम्म। It is not decreasing, man. Okay, it will not decrease. Okay, the question is that बोल रहा है कि this mass m1 is kept on this table and this is made to rotate with angular velocity how much? Omega. किस velocity से rotate कर रहा है? Omega. तो question is find max value of omega so that, sorry, minimum value चाहिए ना, क्योंकि max minimum omega so that, बताऊंगा, so that system remains in equilibrium. I'll tell you. That's what you have to understand. That's why I'm writing it. देखो एक बात बताओ, ये जो मास m1 है ये गोल 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 घूमेगा, है ना, जो कि इस मास m2 को बैलेंस करने की कोशिश करेगा। अगर 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 इसकी ओमेगा कम हो गई तो ये मास m2 नीचे गिरने लगेगा ना। तो अपने को मालूम है कि सबसे लोवेस्ट वैल्यू पे अगर मालूम चल गया कि ये स्टेबल हो गया तो उसके ऊपर अगर जाऊंगा तो भी तो स्टेबल रहेगा ना। अरे बोल सी सी सिंपल सी बात है, एक बात है, अगर मान लो एक थ्रेड है, ठीक, इसके साथ बॉब को अटैच कर दिया, ठीक है, बोला गया कि 50 न्यूटन पे, मतलब अगर ऐसा काम करते हैं, ओमेगा की वैल्यू अगर 10 रैड पर सेकेंड है तो थ्रेड टूटता नहीं है, अगर ओमेगा की वैल्यू मोर देन 10 रैड हो गई तो थ्रेड टूट जाएगा। तो बेसिकली at that case what is your maximum value? 10 rad, because beyond that the thread is breaking, and after that I can pick up any value or not, है ना। I can pick up 9 rad, 5 rad, 6 rad, for which the thread will not break, isn't it? But 10 से कम, हाँ। तो यहाँ पे एक बात बताओ, अगर मैं ये ओमेगा लगा दिया, मालूम है कि इसके घूमने की वजह से ये मास m2 क्या रहेगा? बैलेंस। कैसा रहेगा? बैलेंस। तो अच्छा पहले इसका, नो नो, अच्छा, डू नॉट थिंक अबाउट मिनिमम और मैक्सिमम, जस्ट फर्स्ट ड्रॉ द, फर्स्ट टेल मी व्हाट इज जस्ट ओमेगा, देन आई विल टेल यू अबाउट whether it should be minimum or maximum. No, what? The question is simple. Find omega so that the system remains in equilibrium. Just find omega. Then I'll tell you maximum or minimum. I do not know. Who said who said in equilibrium the body will not move? Yes, equilibrium means the net force is zero, but the body can still move with constant velocity, isn't it? Hmm. So find omega so that the system remains in equilibrium. Find omega so that the system remains in equilibrium. How is Dubai basically? You are in Sharjah or Dubai? Okay, wow. So, okay, let me talk with Imran sir. I'll arrive in Dubai. Just be in Dubai next year. हाँ हाँ हाँ। अच्छा, मतलब हर वहां पे वो सैंड स्टॉर्म वगैरह कुछ ऐसा आता नहीं है ना, मतलब 50 डिग्री सेंटीग्रेड समर में नहीं चला जाता है ना? होता है? अरे भाई साहब। हाँ, बट इन समर सीजन इट विल बी देयर, समर सीजन इट विल बी टू वार्म ना? ओके। ओह वाह। अच्छा। अरे भाई साहब, लेट मी प्लान। Imran sir is telling me to come to Dubai. He's asking me. Yes, I think the way I teach, it will be awesome over there, isn't it? Oh, let us see. I do not know still. If they give me more money, then I'll only come. Find omega so that the system remains in equilibrium. अच्छा देखो, इक्विलिब्रियम का मतलब क्या है कि अच्छा एक बात, सिंपल सी केस है, अगर इक्विलिब्रियम में रखना है तो दिस m2 मस्ट नॉट फॉल, इजंट इट? So that means there will be a force mg, and that the weight of this particular block will be that must be balanced with the tension. So first condition is T is equal to mg, means basically m2g. Sorry, this is m2g. T is equal to m2g for the case of equilibrium. Correct, isn't it? Now next thing is, if this mass m1 is there, if it is rotating with angular velocity omega, so this mass m1 omega square r will be a centrifugal force outside. And since the thread is one, remember that if the thread is one, the tension will remain same at each and every point or not. So it will be T only. So that means if this system wants to be in equilibrium, then this tension T must be also equal to m1 omega square r. So I can write the relation m1 omega square r is equal to m2 g, and omega is nothing but root under m2 by m1 g by r. Are you able to get me or not? Now you see this. This is which velocity of omega? एक बात बताओ, अगर मान लो अगर इससे अगर ओमेगा की वैल्यू इस ओमेगा से जरा सी कम हो गई, क्या हो गई? लिटिल बिट लेस देन दिस ओमेगा, व्हाट विल हैपन? सुनो सुनो, ध्यान से सुनना, अभी मैं जो स्टेटमेंट बोलूंगा वो ध्यान से, इतना दूर समझ लिया? समझ लिया, ठीक। हाँ, तो देखो, बेसिकली सिंपल सी पॉइंट है कि इफ आई आस्क यू that if the value of omega, if this omega which is present over here, if this omega is basically less than this omega which we got, what will happen? Centrifugal force will be less, then the m2 will start falling or not? Why? Because m2g will be more than 10 centi. Make sense? So that means that if my omega decreases from this particular value, the body is not in equilibrium now. So the minimum velocity which should be present should be this much, because beyond this velocity I know that centrifugal force will be able to balance my tension. Are you able to get me or not? मैक्सिमम इसमें तो कुछ भी हो सकता है ना, इनफाइनाइट वैल्यूज पॉसिबल है ना। और बहुत ज्यादा अगर ओमेगा तुमने बढ़ा दिया तो सेंट्रीफ्यूगल फोर्स बहुत ज्यादा हो जाएगा ना, तो बॉडी क्या होगा उस समय? ये m1 बाहर जाने लगेगा और m2 ऊपर चढ़ने लगेगा। आर यू एबल टू गेट मी और नॉट? समझ में आई बात? Yeah. So omega max will appear. It will appear. Definitely, it will appear. I'm going to come on that. So right now we were talking about minimum omega. What can be the means? What can be the value of omega which will just balance this? Right or not? Just like over here, यहाँ पे ये omega की maximum value है, क्योंकि हमें मालूम, हाँ, क्योंकि हमें मालूम है, नहीं नहीं नहीं, हमें मालूम है कि अगर ओमेगा की वैल्यू अगर इससे ज्यादा हो गई तो बॉडी अपने आप नीचे गिर जाएगा। आर एबल टू गेट मी और नॉट? So if you think what is, see, there is nothing called as maximum and minimum. You have to think what is the meaning of maximum over that case. हर केस में अलग अलग सिचुएशन पे अलग अलग मीनिंग निकलेगा मैक्सिमम का, ठीक है। एक फिक्स्ड मीनिंग नहीं है, समझ में आई बात। जैसे यहाँ पे, ये यहाँ पे मिनिमम ओमेगा था। क्यों मिनिमम था? क्योंकि आफ्टर दैट एवरी ओमेगा कैन गिव मी अ स्टेबल इक्विलिब्रियम, ठीक है। लेकिन अगर डिस्क में मैं देखूं, तो अगर मैं ओमेगा की वैल्यू बहुत ज्यादा बढ़ा दूंगा तो ब्लॉक सीधा नीचे गिर जाएगा। तो हमारे पास एक मैक्सिमम वैल्यू ही है, उससे ज्यादा करूंगा तो डेफिनेटली इट विल फॉल, वर्ड और नॉट। So you have to think what is the meaning of that maximum and minimum. Is this clear or not? Even I can't say, I can't make you learn it. I can't make you understand it. It will come to you automatically. Are you able to get me? Just remember, minimum is, हाँ मतलब जस्ट मिनिमम का मतलब क्या है? अगर ओमेगा मिनिमम है, मतलब कोई भी चीज अगर मिनिमम है, तो उसके ऊपर की वैल्यूज के लिए कुछ भी पॉसिबल देखना है, उसके नीचे के लिए ऑटोमेटिकली वो पॉसिबल नहीं होगा। समझ में आई बात? मीन्स इफ आई से there is an event, I'll talk about this. There is an event, quite or not, and then this event has two scenarios, one maximum and then one minimum. What is the if I consider, if for this event I prefer some variable x to be minimum, the meaning of that is these events are always possible for the value of x which are greater than this values. Are you able to get me? So basically, minimum of means for any event which is dependent upon variable x, the meaning of this x minimum is the event is possible. The event is possible for any value of x greater than or equal to x minimum. लेकिन ये इवेंट पॉसिबल नहीं होगा for less than, event is not possible, yeah, x is less than x minimum. Are you able to get me or not? ठीक है। मैक्सिमम का मतलब क्या हुआ? इफ देयर इज एन वेरिएबल एक्स व्हिच इज क्रिएटिंग एन मैक्सिमम वैल्यू ऑफ इवेंट, दैट मींस इवेंट इज नॉट पॉसिबल, या if yeah, x is greater than x max, an event is possible if x is less than or equal to x max, correct or not? So means the probability of event lies between x minimum and x maximum. Are you able to get me or not? For anything to happen, it lies between two probabilities, minimum and maximum. And in one case, it will always only one thing you can tell about. In one event, we can only tell about minimum. We can only either tell about maximum. There are very less scenarios in which we can even talk about minimum and both maximum. Are you able to get me or not? Understood? Now you got what is called as physics. मजा आया? ठीक है। तो ये सारी सिनारियोज हैं, इनको लेके बस बनाते रहो, ये डायनामिक्स कंप्लीट कर देगा। इस क्वेश्चन पे आएंगे थोड़ा लास्ट में आएंगे यार। अभी एक थोड़ा सा और कुछ चमत्कारी करने का मन कर रहा है ना। तो अब देखो, अब मान लो, थोड़ा सा चलते हैं अब असली चीजों पे, जो कि तुम्हें जरूरत पड़ेगी। ये सारे तो न्यूमेरिकल्स थे जो तुम्हें कभी कभी बीच में आ सकते हैं, बट दिस इज मेन थिंग, कर्विकल पाथ्स, द डायनेमिक्स ऑफ कर्विकल पाथ, ठीक है। ठीक। तो ध्यान से देखो, कोई भी पाथ जो होता है, मतलब अगर किसी रोड पे चल रहे हो तो रोड कैसा हो सकता है? रोड थ्री काइंड ऑफ सर्फेसेस हो सकता है। एक ये कॉनकेव वाला हो सकता है ना, है कि नहीं? दूसरा कॉन्वेक्स हो सकता है, और तीसरा कैसा हो सकता है? नॉर्मल सरफेस हो सकता है, स्ट्रेट। आर एबल टू गेट मी और नॉट? अगर मान लो, अगर तीनों पे मान लो, एक यहाँ पे कार ऐसे चल रही है, ठीक है, एक कार यहाँ पे इस टाइम पे प्रेजेंट है, ठीक, और एक कार इस सरफेस पे प्रेजेंट है। मास सेम, तीनों कार के पास जो मास है वो कितनी है? एम है, ठीक है, सेम मासेस हैं, ठीक। एंड ये तीनों के तीनों जो है ना, वो वर्टिकल के साथ, दिस टाइम दिस इज मेकिंग एंगल थीटा विद द वर्टिकल, दिस टाइम this is also making angle theta with the vertical, and this is not making anything with the vertical. Are you able to get me or not? So then if I ask you, in which of the following case the body will feel the very less weight, where what will be that particular answer? देखो, सबसे पहले मैंने पूछा, तुम्हें पूछा डायनेमिक्स में द वर्ड वेट के बारे में, है ना? यस। अच्छा, many people will tell, sir, weight is mg, isn't it? Isn't it? But then why do you, if you go in lift, और लिफ्ट में अगर मान लो एक लिफ्ट में बैठा हूँ, अगर लिफ्ट में मैं ऐसे खड़ा हो जाऊँ, है ना, और नीचे वेइंग मशीन लगा दिया, तो ध्यान से जब लिफ्ट ऊपर जाएगी तो मालूम चलेगा कि तुम्हारा वेट बढ़ गया, लिफ्ट जब नीचे जाएगी तो तुम्हारा मालूम चलेगा वेट घट गया क्या। तो इसका मतलब वेट तो वेरिएबल क्वांटिटी हो गई ना भाई। तो बेसिकली वेट को मेजर कौन कर रहा है, ये एमजी नहीं होता है, वेट इज एग्जैक्टली इक्वल टू द नॉर्मल। याद रखो, weight is nothing but it is exactly equal to what? Normal. The normal, basically simple सी बात है, the normal, whatever is the reaction from the ground, that is basically going to get, or that is going to basically tell about the weight of a body. Are you able to get me or not? Understood? मजा आया, नया चीज सीखा। सो वेट क्या होता है? नॉर्मल, सिंपल सी बात है। जैसे यहाँ पे अगर ये रिजिड सरफेस है तो इसकी जो फोर्स लगेगी, द वेट कॉम्पोनेंट mg नीचे लगेगा, और इसका नॉर्मल कहाँ लगेगा? ऊपर। तो बेसिकली नॉर्मल इज इक्वल टू mg, एंड दैट्स व्हाई वी से वेट इज इक्वल टू हाउ मच? mg। सारे केसेस में होगा। आर एबल टू गेट मी और नॉट? ठीक, तो ध्यान से देखो, जब व्हेन आई केम ओवर हियर, दिस पर्टिकुलर कार एट दिस इंस्टेंट ऑफ टाइम will have some velocity in this particular direction or not? Is this clear or not? So if the radius, if this particular radius is r, this is what? R, then the body will feel an centrifugal force mv square by r outside or not? And this is my weight direction. The weight of the body is vertically downwards. You know that car has some weight which will be vertically downwards, which will be exactly equal to how much? mg. So if I see, अच्छा अब ध्यान से देखो, इसको मैं थोड़ा सा अच्छे से जूम करके बनाता हूँ, ठीक, ताकि तुम्हें समझ में आए। दिस इज माय कर्विकल कॉन्वेक्स पाथ, ठीक। यहाँ पे तुम्हारा कार मान लो मास m का है, जिसके पास वेलोसिटी कितनी है? v in this particular direction. Now this is my vertical direction, this is angle theta. So you got, this is my radius r, this is your mv square by r, centrifugal force outside, but the weight component will be vertically downwards, which is going to be equal to how much? mg। अगर ये एंगल थीटा तो ये भी एंगल क्या हो गया? थीटा। तो इसके वजह से इस डायरेक्शन में mg का एक कंपोनेंट आ जाएगा ना, क्या होगा? mg cos थीटा। अच्छा अब एक बात बताओ, तो इस मास m अगर कर्विकल सरफेस पे आ जाओ तो हम नॉर्मल कैसे ड्रॉ करेंगे? If it is a straight surface, you know that normal is perpendicular to that, but for curvical surface, how to draw that? Yes, so velocity, this velocity is present in this particular tangent direction or not? And, and perpendicular to this tangent. Remember that normal is always perpendicular to tangent. ठीक है, तो यहाँ पे नॉर्मल बाहर रहना चाहिए, अंदर रहना चाहिए? बाहर कैसे? हेवियर बॉडी लोअर मास के ऊपर रिएक्शन जनरेट करती है ना। If there is a ground and if I keep a block of mass m, then basically the normal, this normal is considered or not? There is also a normal present on the ground, but this normal is not sufficient enough for the heavier body to fill it or not. So that's why we ignore this normal. Are you able to get me or not? Understood. Okay. So this is my normal over here. Are you able to get me or not? So basically over here, if I see what is my normal, normal is nothing but mv square by r plus how much? mg cos theta. Are you able to get me on? So on curvical surface, this is my direction of normal. This angle is theta. So mv square plus mg cos theta is my on a which kind of surface? I think it is called as concave. ठीक है? So on concave surface, my normal is how much? Mg cos theta plus mv square by r. Is this clear or not? मेरी बात समझ में आई? अब ध्यान से देखो, if it is convex surface, I'll do a bigger diagram for that. If this is my convex, if this is my block of mass m moving over here, this is my direction of velocity, isn't it? And then this will be my angle theta or not? So every time I'm considering angle theta with respect to what? Norm, with respect to vertical. Are you able to get me or not? So once again, the centrifugal force will be inside or outside? Always outside. Why there is a confusion? I'll kill you. Centrifugal force it will be always where? Outside. So mv square by r once again mv square by r outside, isn't it? ठीक है, देखो मैं इस एम बी स्क्वायर का कोई कंपोनेंट वगैरह कंसिडर नहीं कर रहा हूँ क्योंकि सर्कल इसी तरह का बन रहा है, ऐसा गोल सर्कल बन रहा है। आर एबल टू गेट मी और नॉट? ठीक, तो एम बी स्क्वायर बाई आर इज रेडियली आउटसाइड। वंस अगेन द एम जी विल हैव, अब एम जी कहाँ रहेगा? नीचे, वर्टिकली डाउनवर्ड्स, परफेक्टली करेक्ट। दिस इज द डायरेक्शन ऑफ एम जी। नॉर्मल की डायरेक्शन किधर? फ्रॉम द हेवियर टुवर्ड्स द, it will be along mv square by r because normal is always perpendicular to tangent and from the heavier to the lower mass. Are you able to get me or not? तो, तो ये एंगल थीटा होगा कि नहीं होगा? तो mg का दो कंपोनेंट आएगा, एक इस डायरेक्शन में, ये वाली वैल्यू क्या होगा? mg। तो बेसिकली आई कैन राइट ना n plus m, if the body is in contact n plus mv square by r must be equal to mg cos theta or not? Yes. So basically this normal is how much? Mg cos theta minus mv square by r. Are you able to understand me? So basically, if this has velocity v, this is mg, this is mg cos theta, if this angle is theta, and then this is my normal plus mv square by r. So on convex surface, my normal is nothing but mg cos theta minus mv square by r. Are you able to understand me or not? So out of these three cases, you see, this is my n is equal to mg. In concave surface, this is mg cos theta plus mv square by r. While in in concave it is mg cos theta plus mv square by r. While in convex it is mg cos theta minus mv square. So that means this value is my maximum value and this value is my minimum value, isn't it? So basically, where my body will feel the less weight? On which surface? Concave, convex, and straight surface? Convex. Why? Because normal is going to measure my weight. Are you able to get me or not? So out of these three, if someone asks you out of these three cases where the body will feel the less weight is present on which surface? Convex surface और bulging out surface. समझ में आई बात? मेरी बात क्लियरली समझ में आई या नहीं आई? But remember that there is always a scenario that people will talk that when the body is moving in this particular path, when it is going towards vertical, the particular normal means particular weight is increasing or decreasing. अब मैं देखो यहाँ पे जो normal है वो थीटा एंगल पे डिपेंड कर रहा है या नहीं कर रहा? तो जैसे जैसे थीटा वैरी करेगा वैसे वैसे नॉर्मल वैरी करेगा ना। तो इसका मतलब क्या हुआ कि जैसे जैसे थीटा वैरी करेगा तुम्हारी नॉर्मल की वैल्यू वैरी करेगी और तुम्हारी वेट वैरी करेगी, है ना? So if I consider the respective case, matlab if I just consider respective cases, if I move from this horizontal path towards this inner part. As I go from this particular point C to D, if I move from C to D, basically theta is decreasing, isn't it? Previously it was 90, now it will become how much? 0. And you want to tell me cos 90 is how much? 0. While cos 0 is basically 1 or not. So basically when I move from this part towards, if I move from point C to point D, my value of cos theta is increasing or not, although the theta is decreasing. तो cos theta इंक्रीज हो रहा है, तो इसका मतलब क्या समझ में आया, क्या मेरा नॉर्मल का वैल्यू इंक्रीज हो रहा है? So can we say for respective case normal is minimum at C while maximum at N is maximum at D? Are you able to get me or not? So when you move down, weight increases or decreases? It increases because normal is the measure of weight. As I move, what we are observing that from C to D normal is increasing, becoming maximum at D. That means weight is maximum at D while minimum at point C. Are you able to get me or not? Understood? Consider the next case, which is convex. If I consider convex, then once again, if I see, once again consider this as base ground. This is point C, this is point D. Once again, when I move from C to D, theta is, when I move from, कहाँ से कहाँ जा रहे हैं अपन, C से D तक, तो जैसे C से D ऊपर की ओर चढ़ने लगेंगे, थीटा की वैल्यू बढ़ेगी या घटेगी? हाँ, when I move from C to D, theta will increase or decrease? It will. अरे भाई यहाँ इधर ध्यान से देख, ये देख यहाँ पे ये वैल्यू थीटा है ना, तो यहाँ पे क्या है 90, जैसे ही ऊपर बढ़ने लगूंगा ये थीटा की वैल्यू घट रही है ना, अरे yeah, so theta is decreasing. So once again you know that if theta decreases, cos theta value increases or decreases? Cos theta increases. Now you look over here. If I see n is equal to what it is, mg cos theta minus mv square by mg cos theta minus mv square by. So as I move upward, mg cos theta is increasing or decreasing? It's semi loudly. It's increasing or decreasing? It's increasing. So if it is increasing, the value of normal is increasing or decreasing? It is increasing. See, look over here. If I just consider over here, the basically if I am over here, the value of normal is decreasing. Sorry, the normal is minimum. If I go at D, since cos theta increases, the value of normal becomes maximum. So once again, when I'm moving from C to D, normal is minimum at C, but normal is maximum at D. So once again, weight increases. यही नीट 2022 में पूछा था. And many people will say that weight is decreasing क्योंकि उनको लगता है कि ऊपर जाने से क्या होगा, cos थीटा की वैल्यू ऊपर जैसे जैसे जाऊंगा, अपन का जो नॉर्मल इसमें से mv स्क्वायर की टर्म जो है ना वो घटते जाएगी घटते जाएगी घटते जाएगी, इसके वजह से जो मेरा पर्टिकुलर है वेटलेसनेस फील होगा. बट ऐसा होता नहीं है इन रियलिटी. In reality, weight increases. Weight is still increasing due to the presence of this angle theta, which I am considering with respect to my vertical. Are you able to get me or not? Understood? Is this clear? So basically, what is the meaning we got it? That when I am moving, see, if I just compare all these three cases, then the minimum weight is present on convex surfaces while maximum is present on concave, and straight is just a normal thing. But when I go from respective cases, what do we observe? That if I approach from C to D, weight is increasing. Here also, if I approach from C to D, weight is increasing. Are you able to get me? Is this clear or not? Understood perfectly. So this is your consideration. Are you able to get me? And this is how we consider it. The dynamics of normal on the curvical surfaces. Totally correct now? So basically, you have to think that theta is always taken with respect to vertical, and that's how we have to remember that weight increases in both the surfaces. While if I just consider all three cases at the same instant of time, then minimum is on convex, maximum is on concave, while it is just neutral on surface. Okay, so this is the one of the best thing which I have taught you. Remember that. Okay. This is not written in many books. Many books they ask the question, but they do not give this particular thing. ठीक है? Okay, got it. So, should I frame one question based upon this? Wanna do a hard question? Wanna do a hard question? This is your homework. Tomorrow I'll discuss about that. Okay. This is this you have holidays now? हाँ तो बस समझ लो हर दिन क्लास है तुम्हारी. हाँ बीच में एक दो दिन का गैप ले लूंगा मैं. This week every day. Properly in the sense weekly 9 p.m. only. 9 p.m. 9 p.m. only. 9 to 9:15 p.m. Okay, between that only. Leave Saturday and Sunday. Okay, Sunday it will be morning. Saturday then it will not be there. Okay. I'll, Monday to Friday means see except Thursday, Monday, Tuesday, Wednesday. You'll have the classes at 9:15. Then Thursday you do not have 9 or 9:15. Both can be possible. 15 minutes I can have also some lunch or something like that. Okay. So Monday, Tuesday means whatsoever is that I do not know. Monday, Tuesday, Wednesday, and Friday it's 9 or 9:15. Saturday it's not there. Then on Sunday you will have morning class. Okay, morning. Let's consider 10 a.m. Is that clear? Yeah. Is that perfect? Or should I do it 11 a.m.? Should I do it 11 a.m. or should I do it 10 a.m.? Yeah. Okay then. Okay. So 11 a.m. IST. Okay. So you will have the class on Sunday 11 a.m. Monday, Tuesday, Wednesday. So almost 5 days classes I'll take till your holidays. Then I'll decrease it. Okay. Yeah. Yes. You can take a break. Hmm. Hmm, 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 hmm. I want a perfect cyclist. Back. Okay. HCM. Okay. This will be your homework. I'll discuss this dynamics tomorrow. Find the. I'll just. No, I'll just tell explain this question. This is an awesome question. ठीक है? Yes. So this is called as a cyclist on a curvical path. ठीक है? और यहाँ पे in this whole path the friction is present. Okay. This is a rough kind of surface. Okay. So between the cyclist and the surface, you have the friction as mu. Okay. Mhm. So coefficient of friction between cyclist and the surface is mu. So see, there is a right now we discussed there are two kinds of surfaces, concave and convex. What we did, we combined both the surfaces. So there is an ABC part which is a convex part, and then there is CDE part which is a concave part, isn't it? Huh. Basically, if I combine this concave and convex part, the question is, yeah, so basically a cyclist starts to move from point A, okay? And throughout this whole path, it tries to maintain this velocity as constant. Are you able to get me or not? Okay, so question is find the maximum velocity of V so that the particular cyclist will not slip and identify which is the most dangerous path. Second question is the most dangerous path. मतलब out of these A, B, C, D, E, and E, there are six parts now. A to B, B to, sorry, four parts. A to B, B to C, C to D, D to E. Out of these four parts, there are some paths where there is a highest chance of slipping or not. So you have to identify that most dangerous path, got it or not? And maximum value of V for which the cyclist does not slip. So this is your homework. You have to do, you have to identify, and then you will have to describe me or tell me tomorrow. Okay? So before that, yes. So this is your homework. You will have to complete, then I'll move ahead. Before that, we'll solve this one question. Do it. Mm-hmm. A particular, I'll just repeat this. There is a rod, okay, of length 20 centimeter, wide or not, and pivoted near a end which is made to rotate in horizontal plane. द कांस्टेंट एंगुलर स्पीड ओमेगा, ठीक है। इसके साथ एक थ्रेड अटैच कर दे रहा हूँ जो मास एम, इसके साथ एक बॉब अटैच कर दिया, और वो थ्रेड किसी एक पर्टिकुलर एंगल थीटा को पकड़ के रोटेट कर रहा है, ऐसे गोल 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 घूम रहा है ना। तो इस एंगुलर स्पीड ऑफ ओमेगा, इस ओमेगा की वैल्यू कितनी होनी चाहिए इफ दिस थीटा इज 30 डिग्री? ज्यादा हार्ड थोड़ी ना है। ये तुम्हारा इसका एच सी वर्मा का है ना, एच सी वर्मा एग्जाम्पल नंबर 8, ठीक है। Are you also going to try for JEE or just NEET? Perfectly NEET. Strictly NEET. Okay then. I'll not give you hard questions then. एक तो ऐसे हार्ड क्वेश्चन पिकअप कर सकते हैं ना कभी ना कभी। अच्छा पीसीएम भी है, तब तो फिर अच्छा है। मैं डैड को सजेस्ट करता हूँ, लेट हिम, आई एम हैंडलिंग फिजिक्स, आई लिटिल बिट मेक इट टफ फॉर हर, let her even give the JEE exam. No, 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 let you will give JEE and NEET both. Okay, do this question. You'll have to practice a math a lot. You can try. You can try. You can manage. Everything can be managed. बनाओ पहले इसको बनाओ, फिर आगे बढ़ते हैं। बनाओ आराम से बनाओ, कोई दिक्कत इसमें सॉरी वगैरह क्या बोलेंगे। चलो। ओके, डू इट फास्ट। अच्छा बताओ, इस पर्टिकुलर सर्कुलर पाथ की रेडियस क्या होगी, पहले वो बताओ मेरे को। सिर्फ फेल होगा क्या? सोचो जरा। बेटा एक बात बताओ, सेंटर तो यहाँ है ना, मास यहाँ पे है, तो ये जो मास है ये कहाँ पे सेंटर पकड़ के घूम रहा है, इसको सेंटर। क्यों? क्योंकि ये पाइवटेड है यहाँ पे, तो ये मास एम कैसे घूमेगा, यहाँ से ये बड़ा सा सर्कल बनाएगा ना, इसको रेडियस मान के ऐसा सर्कल एक बनाएगा ना, तो बेसिकली जो रेडियस हुई वो क्या होगी, ये लेंथ तो एल हो गया, ये एल है ये थीटा है, तो ये लेंथ कितना होगा, एल साइन थीटा। इसकी जो नेट रेडियस हुई वो हुई कितनी, एल प्लस एल साइन थीटा। गॉट इट? ऐसा होगा क्या? रिमेंबर व्हाट इज रेडियस, रेडियस इज द line joining the axis of rotation and the particle. Are you able to get me or not? ठीक है, भूलना नहीं कभी अब। So now once again if I say radius is the line joining axis axis of rotation and particle, ठीक है। This is my radius in terms of this, in terms of omega radius is, ठीक है। How to define radius? उसमें बताया था ना, वो ऑब्जर्वर के रिस्पेक्ट में हाँ, तो इन टर्म्स ऑफ ओमेगा इट इज लाइन ज्वाइनिंग, दो डेफिनेशन है, लाइन ज्वाइनिंग द ऑब्जर्वर एंड द पार्टिकल, ठीक है। आर एबल टू गेट मी और नॉट? तो देख ध्यान से देख, इस डायरेक्शन में टेंशन टी होगा, है ना, है ना। तो ये मास एम हो गया, मास एम के ऊपर ये हो गया तुम्हारा टेंशन टी, है ना। तो इसके ऊपर सेंट्रीफ्यूगल फोर्स बाहर जाएगा, इट विल बी हाउ मच एम ओमेगा स्क्वायर। अगर ये ओमेगा से घूमेगा तो ये भी ओमेगा से घूमेगा ना, क्योंकि बॉडी अटैच्ड है। आर एबल टू गेट मी और नॉट? and that r will be how much? L plus L sin theta. Are you able to get me? बोल हाँ या ना? Okay, so this is angle theta. If that is theta, so this angle will be also what angle? Theta. If this is above of mass m, so this will be what? mg नीचे, है कि नहीं? तो टेंशन के दो कंपोनेंट t cos theta, t sin, क्यों करेंगे? वर्टिकल है ना, ठीक। तो अपन लिख सकते हैं ना t cos theta is equal to mg and t sin theta is equal to m omega square L, sorry, m omega square L plus L sin theta, right or not? क्यों रिजॉल्व करें? क्योंकि टेंशन से हम बैलेंस करके निकाल सकते हैं ना। अगर हम सिर्फ अगर अच्छा हाँ, बहुत अच्छा तूने क्वेश्चन पूछा सर। सर तुम जो सर जो करते हो ना, सर रुक जाओ बता रहा हूँ। ये जो सर की जो डेफिनेशन है ना, तुम लोग चेंज कर डालते हो। देख ये मास है मैं, ठीक। मैं बोला इधर लग गया तेरा एम वी एम ओमेगा स्क्वायर आर या एम वी स्क्वायर बाई आर, ठीक है। अभी मैंने बोला इसके नीचे लगा क्या? एम जी, ठीक। तो पहले वाले केस में, जब पहला वाला जो केस था, जब वो वर्टिकल वाला हो रहा था, तो वर्टिकल वाला याद कर दे, ये है एक तरह से हॉरिजॉन्टल सर्कुलर मोशन ना, ठीक है ना। दूसरा कौन सा था? वर्टिकल सर्कुलर। क्यों? दिखाई पड़ेगा कि नहीं दिखाई पड़ेगा अच्छे से? समझ में नहीं आ रहा है क्या? ये देख, ये कैसा घूम रहा है, ये गोल 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 ऐसे हॉरिजॉन्टल वे में घूम रहा है ना। समझ में आई बात? दो तरह की मोशन हो सकती है ना, एक मैं पेन मेरे, ये पेन दिखाई पड़ रही है तुम्हें? वीडियो का, ठीक है। तो ध्यान से देख, इस पेन को मैं ऐसे 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 गोल गोल हॉरिजॉन्टल वे में घुमा सकता हूँ, या फिर ऐसे वर्टिकल वे में भी तो घुमा सकता हूँ ना। मतलब ऐसे ऐसे समझ, एक धागा ले लिया, धागा को हाथ से बांध दिया और ऐसे गोल 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 घुमा रहा हूँ, तो वो कौन सा मोशन हो गया? हॉरिजॉन्टल सर्कुलर मोशन। लेकिन एक पेंडुलम मोशन देख लिया, तो वो कैसा हो गया? वर्टिकल। आर एबल टू गेट मी और नॉट? तो जब वर्टिकल सर्कुलर मोशन आएगा, तो हाँ, तो वर्टिकल वाले में क्या हो जाएगा? वर्टिकल वाले में जो टेंशन टी होगा वो ऊपर होगा, है ना। एम जी कहाँ रहेगा? नीचे। एम जी स्टिल इट इज डाउनवर्ड्स, लेकिन वर्टिकल में जो सर्कल है वो इस तरह से डिस्क्राइब हो रही है ना। तो इसकी वजह से जो एम वी स्क्वायर बाई आर आ रहा है, वो टेंशन के ही डायरेक्शन में आ जा रहा है ना, बिकॉज टेंशन इज इन द डायरेक्शन ऑफ रेडियस, एंड एम वी स्क्वायर बाई आर विल बी ऑलवेज प्रेजेंट अपोजिट टू द डायरेक्शन ऑफ रेडियस और नॉट, ठीक। तो ध्यान से देख, ये हो गया तेरा वर्टिकल सर्कुलर मोशन, लेकिन हॉरिजॉन्टल वाले में क्या हो जाएगा? वेट, ठीक है। एक मिनट में तेरे को गूगल से इमेज निकाल के दिखा दे रहा, थोड़ा सा अच्छे से कर लेते हैं, एक मिनट। वर्टिकल, वर्टिकल सर्कुलर, सर्कुलर मोशन इमेज, यस, इमेजेस। अरे भाई साहब, थोड़ा दिखा है अच्छा सा भाई। हाँ, ये इमेज सही है, मजा आ गया। ये इमेज सही है, कॉपी इमेज। मैं तेरे को समझाता अपन अच्छे से। अरे भाई साहब 1 मिनट, 1 मिनट, हाँ। अभी ठीक है? ठीक है, थोड़ा बहुत ये ऐप थोड़ा बहुत हैंग कर सकता है। 1 मिनट। पता नहीं जूम आउट जूम इन क्यों नहीं हो रहा है। सो डेस्कटॉप हॉरिजॉन्टल सर्कुलर मोशन, 1 मिनट। इमेज, ये हो गया कॉपी इमेज। ठीक है, हाँ, तो ध्यान से देख, कुछ नहीं है, कुछ इसमें है ही नहीं, तो इतना तो सोचने वाली बात ही नहीं है, मैं तो इतना सोचूंगा ही नहीं। देखो, दिखाई पड़ रहा दोनों इमेज? अब समझ में आई बात मैं क्या बताना चाह रहा था? अब देख, ध्यान से देख, अब ध्यान से देख जरा, ये दोनों हैं अलग अलग केस। ये हो गया तेरा वर्टिकल, हॉरिजॉन्टल, ठीक। तो जब वर्टिकल में मैं कंसिडर करना, मान ले मैंने एक काम किया, एक पकड़ लिया ऐसे, 1 मिनट, लेट मी कंसिडर वन सेंटर, एक मैंने ऐसे थ्रेड लगा दी, ठीक, और इस थ्रेड पे बोला बेटा एक बॉब को गोल 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 घुमा दिया, है ना? तो ध्यान से देख, जब ये सर्कल इस तरह का वर्टिकल है ना, तो जो भी सेंट्रीफ्यूगल फोर्स होगा वो रेडियली आउटसाइड होगा, है कि नहीं? इस तरह से, है ना? तो जो डायरेक्शन ऑफ टेंशन है, दिस इज माय डायरेक्शन ऑफ टेंशन टी और नॉट, एंड डायरेक्शन ऑफ mg विल बी डाउनवर्ड्स और नॉट। तो उसके लिए, हाँ, उसके लिए जो mv स्क्वायर बाई r आएगा वो किधर रहेगा? इस डायरेक्शन में होगा ना? सेंट्रीफ्यूगल फोर्स बेटा आउटसाइड, रेडियली आउटसाइड, चीटा फ्रेम पे हम बना रहे हैं, ठीक है? तो डेट विल बी, ठीक। तो मान ले इस टाइम पे ये जो एंगल है वो क्या है? एंगल थीटा है। तो ये भी एंगल क्या हो गया? थीटा। तो mg का दो कंपोनेंट आएगा ना, एक देख ध्यान से देख, ये mg इधर आ जाएगा, mg cos थीटा। तो हम क्या बोले? टेंशन T इज इक्वल टू mg cos थीटा प्लस mv स्क्वायर बाई r। आर एबल टू गेट मी और नॉट? मेरी बात समझ में आई? ठीक। तो देख, अगर अगर हॉरिजॉन्टल लूं तो हॉरिजॉन्टल में यहाँ पे इस टाइम पे इसकी वेलोसिटी v, तो यहाँ पे mv स्क्वायर बाई r इज एग्जैक्टली इक्वल टू टेंशन T और नॉट। बट एक जो हॉरिजॉन्टल सर्कुलर मोशन है वो कुछ इस तरह का भी हो सकता है। 1 मिनट, एक और मेरे को हॉरिजॉन्टल सर्कुलर मोशन का देखने दे। बेसिकली, हाँ, ये वाली इमेज चाहिए थी अपन को, इस तरह की इमेज कुछ मिल जाए तो अपन का चमत्कार हो जाएगा। ओ बेटा जी, किस्मत की हवा कभी नरम कभी नरम, ठीक है। इसका कुछ और प्रोटोटाइप है? एक दो और प्रोटोटाइप नहीं मिल रहा है। हाँ, ये वाली प्रोटोटाइप सही है, या इसी को ले सकता हूँ, ठीक है। इसको एक बार डिलीट मारने दे। ये वाला समझ में आ गया ना? इसको मैं डिलीट, है ना, इसको हटा रहा हूँ। हाँ, अब देख, अब मैंने लगाया कंट्रोल पे। अरे तेरी, बहुत बड़ा हो गया ये तो छोटा कर सकता हूँ। आई डोंट नो वी कैन decrease it or not. It's not getting decreased. 1 minute. I want to compare. हाँ हाँ हाँ, it's not. I will not delete it. I need perfect image. ध्यान से देख, 1 मिनट, छोटा सा इमेज मिल जाएगा, छोटू सा, उनका काम हो जाएगा। ये वाला इमेज काम आ जाएगी। कॉपी इमेज, कंट्रोल भी। What the hell is this? Delete. This image is not appearing. Oh, that is a background image. What the hell is happening, man? Yeah, I can consider like this way. It is also. 1 minute. Just give me 1 minute. Images for horizontal circular motion. Background. ये वाली काम आ सकती है कॉपी। ये इमेज समझ में आ रहा है ना? इस इमेज को कॉपी कर लेते हैं ना? ठीक है। अरे भाई ये भी डिक्रीज नहीं होगा। तो यार अच्छा एक एक मिनट मैं ऐसे ही ड्रॉ करके दिखा दे रहा हूँ है ना? ठीक ध्यान से देख। अल्टीमेटली आई विल हैव टू ड्रॉ। अब ध्यान से देख अगर अगर अपन को नॉर्मल हॉरिजॉन्टल सर्कुलर मोशन तो पता है बट अपन एक काम कर सकते हैं if this is my vertical means if I just take a pendulum and I do not oscillate it, I do not oscillate it, what I do is I take this pendulum and then I provide such a tangential velocity that it starts to rotate in this kind of fashion, right or not? है कि नहीं? तो ये भी तो एक हॉरिजॉन्टल सर्कुलर मोशन हो गया ना? Okay, but that time pendulum will be fixed at angle theta. Are you able to get me or not? Here, this theta is variable. In this vertical circular motion, the theta is variable. As the body will go up and up, this theta will increase and this theta will go on increasing. Are you able to get me or not? But here, my theta is fixed. Are you able to get me? So if this is my mass m, this is mg. For this particular body, this is my radius because the velocity is in this particular direction. Are you able to get me or not? And therefore mv square by r is present radially outside and that will be how much mv square by r simple. Then once again I say that this is my value of tension. In this direction I'll have tension t and then there will be two components here. I'll resolve tension now. I'll call this as T cos theta and I'll call this as T sin theta. Is this clear or not? So ध्यान से देख what is the biggest difference between horizontal and vertical? Why I compared this? Why I did this? Horizontal circular motion. ठीक ध्यान से देखना जरा कि if I consider vertical, I'm resolving my weight component. Are you able to get me or not? Tension remain as it is because if I resolve tension, there is a presence of extra force over here. Are you able to get me? But here in horizontal case, I have these two forces in directly one in vertical, another one in horizontal direction. Are you able to get me or not? So which is most easiest thing? I can resolve tension T easily. Is that clear? So one of see अगर तुम्हें जल्दी क्वेश्चन बनाना है तो आइडेंटिफाई कर लो if that is a circular motion identify which kind of circular motion it is vertical or horizontal. If it is vertical resolve mg, if it is horizontal resolve tension. Understood? Now got the point? Got it or not? यही सबसे बड़ा confusion होता है. Are you able to get me? So basically, if I have this horizontal, this is my tension T. This will be angle theta. This will be T cos theta. This will be T sin theta. Is this clear or not? And if it is vertical, just this is T. This angle is also theta. So in this direction, I'll have to take mg cos theta. Understood? Okay. So here, which kind of motion is this? This is a horizontal circular motion, no? Obviously. So basically, I'll resolve what? Tension. So T cos theta, T sin theta, and I got T cos theta is equal to mg, T sin theta is equal to m omega square L by L plus sin theta. If you divide, you'll get tan theta is equal to omega square L plus L sin theta divided by how much? G. Put all the values, you'll get omega. Are you able to get me or not? Understood? मजा आया? Got it or not? ठीक है. So we completed many things today. I'll share you this PDF of this now. Okay. You go through this once. You check through this. Then do this question. Then we'll meet with this particular problem, bending of cyclist, and banking of car, banking of road and road cases, and then the particular vertical cases tomorrow. Okay, ठीक है। तो ये सारी चीजें अपन आज कंप्लीट किए। एक बार देख लेना, जाके रिवीजन कर लेना। बहुत सारी चीजें मैंने बहुत अच्छी अच्छी चीजें बताई हैं। हॉरिजॉन्टल के केस में सिर्फ टेंशन को रिजॉल्व करना है, वर्टिकल के केस में किसको रिजॉल्व करना है, एमजी को रिजॉल्व करना है। ठीक है। ठीक, उसके बाद दूसरा चीज देखा डिस्क वाले प्रॉब्लम्स में, ओमेगा मिनिमम ओमेगा मैक्सिमम इवेंट के टर्म्स में देखना है। मिनिमम का मतलब होता है कि उस पर्टिकुलर वैल्यू के ऊपर ही सारे इवेंट पॉसिबल है, उसके नीचे पॉसिबल नहीं होगा। मैक्सिमम का मतलब है कि इसके ऊपर पॉसिबल नहीं होगा, उसके नीचे पॉसिबल होगा। आर एबल टू गेट मी और नॉट? ठीक है, तो ये सारी चीजें अपन ने कंप्लीट की। मीट वंस अगेन टुमारो, बेस्ट अपॉन दिस, देन विल मूव अहेड। ओके।